Hey, Coffee Compiler Club. Here today to talk about, well, in theory, compilers and type systems, but maybe, risk management software and the collapse of the housing markets. I don't know. We always have some conversation running before we start filming. Everyone's being recorded live. You show up on YouTube in a couple hours. I don't have any set agenda. Um, that's it. Guess I should put my self view on. And there it goes. Boom. Anyone want to start something? I can pull out the paper.
Yes. So thinking about the risk management stuff made me think of all the languages like J and KDB
Yeah.
and the array languages that a lot of the sort of market
Ah,
analysts really like. And they tend to have
H2Os.
this philosophy of at the top level, they have a very slow interpreter, but most of what you're actually doing and where the actual cycles go is
Yeah,
calling into very highly tuned
right.
linear algebra functions that do
It's the
things
Python
on big
model
arrays.
and R as well.
What do you think about having a proper JIT that actually is going through everything versus this model of the orchestration code should all just be in some slow interpreted thing that's really about developer time
That
and
was
nice feedback cycles
that was the
and
H2O
only having
model.
a little bit of
Or,
the brute forcey.
or I should say that is the H2O model. I think they're still in business. You write in Java instead of in R or Python. Is that good or
But Java
bad?
is JITted.
And then the back end all does whatever it does with whatever terabytes of data it gets. Does something good and fast. But
You know,
the draw for people like Python and R is the well integrated command. I want to say command line REPL, well integrated REPL.
I mean, I know the joke at YouTube used to be that 99% of the code that runs YouTube is in Python and 99% of the cycles that run YouTube is in C++.
Yeah, yeah, exactly. They're not alone, and I don't know if that's still true this day, but it totally makes it makes some amount of sense in that it's an easy place to grow into, um, because you get to start with you know something small and modest and then easy to work with REPL. And then when it
Yeah.
got slow, you took the slow piece and you put it in a C++.
Yeah. So I think it makes sense in general to put a lightweight front end language in order to express the problems and
Yeah.
write their solution in more details and arguably faster
REPL,
implementation. Yes.
a well integrated REPL.
Yeah.
Yeah. And that's what Jupyter notebooks and things like that were all about.
Yeah.
Taking
Yeah.
when you finally got a little more stability on your data science that you're doing, you could.
Prototyping quickly it's instrumental to iterate on your ideas. So the, the new languages has to have a good support for that.
All right.
Hmm. How about a recap on the in-person CCC?
Oh, the in-person one. Jeez. Well, that was a lot of fun. Actually, it was a lot of fun. I don't know, it was Arthur, me, Yasser, his roomie, Colin, and Matt showed up after an hour. And we just talked all over the place with compilers. And mostly, not mostly, but a big chunk was Arthur pointing out the LLVM model has its merits, and me and Yasser pointing out that Sea of Nodes has its merits. And
Which
these two
which
have
is
some cross.
which is the quick version of the LLVM model? You
Well,
mean more?
the thousand passes, the pass
Oh,
after pass, and I say
more
thousands,
passes.
and he said it's like 2,000 if they run a heavyweight version or whatever. It's like ludicrous count of passes.
But did they traverse all
Yeah.
the
But a
all?
lot of
that
that
is
is
all?
running
Running the same passes over.
Yeah. Yeah,
So
but their point is each pass individually is very simple on its own. That was his main thesis.
mhm.
Although, Yas and I were pointing out that the interaction between passes, especially at that count of passes, takes you well past the understandability point and into the, geez, I don't know how to solve this except throw yet another pass in to do something that coulda, woulda, should have been done earlier, but we
So
didn't have the
so did
info. And
did they combine passes? So let's
they
say for
they the philosophy is you get a one pass to do one thing, and then you throw another pass in.
So the one of the Scala tricks new the Scala tree compiler it's actually combined phases together. So they took small phases. They're like let's say they are a function. So you apply the transformation while you traverse
Yeah.
instead of traversing it again. So that is a good strategy, but you have to have something in place in order they do not have to step on each other's
Yeah,
toes.
right.
So
I'm not the LLVM expert. This is like known since I was in grad school.
mm,
I assume LLVM does some of that some of the time. And I don't know where they stand. And
mm,
then, the sea of nodes thesis is that that's taken to the extreme and every little thing is done in the same one pass incrementally every step of the way. And
mm,
you get this different thing. So one of the things that surprised me out of this, and I'm sure I'm going to put words in Arthur's mouth, so I apologize now, was he didn't understand the putting the memory in the sea of nodes graph really puts memory in the sea of nodes graph. Like it disappears as a separate thing. It's just yet another memory, another edge, another node, another edge. And the transformations that are involved don't know, don't care about memory versus not the memory. And that was one of the things that he didn't get
mm.
or didn't have well embedded in his head. And that turns into there's never any issue about aliasing, and you never have to care or track aliasing info. It comes for free out of all the graph transforms, and there's no updates to it, and there's no loss. You
You
can't get
mean
wrong.
you mean modeling the memory inside of the Sea of Nodes framework,
Yeah,
as you said.
right.
Right.
Modeling the memory in the sea of nodes was surprising to an LLVM expert who's heard the sea of nodes talk plenty.
Hmm.
So that was surprising to me that that still didn't stick.
Hmm. That sounds about right to me. So when we spoke the last time, when you say new, you automatically boil down to the most basic parts what a new could mean, and that includes, I believe, a
Yeah,
memory state.
yeah,
Yeah.
yeah. I mean, Simple has the implementation of it now. That's actually reasonable. I've gone back and forth on the how the details of it go, but the big picture is always the same. Somebody gives you a pointer, somebody has a state of memory, and they pass it along and they modify it. That state of memory gets shattered into independent alias pieces that are all free floating and updated independently.
Hmm.
And at that point, it looks like another edge, like a integer add or a floating point
So how
op.
does
It's
that
just
work
another
with
edge in the graph.
choosing implementations? One of the big tricks for getting things to go faster is to have one version of memcpy that does a bunch of checking to see if they overlap in ranges, and another version of memcpy that knows that the two buffers don't overlap with each other.
Yeah, how
How
do
do
we get
you
into
in a
memcpy from here?
So if you have a memory that's in your sea of nodes,
Uh-huh.
how are you tracking it? Because now I'm trying to stamp down a function call and I have to know, hey, this is a
So,
function of a memory and another memory,
right,
but I want to know, are they maybe overlapping or not maybe overlapping?
right. Now you're confusing pointers and memory.
I believe the
So,
memory I believe the memory is modeled like a separate thing. It doesn't have a place, a concept of place. It's
yeah.
something that you have to account for it, but you didn't say where. The
So,
where becomes a implementation at the end.
well, I think the thing that Aaron's looking for missing here is that the aliasing info in Sea of Nodes is, how do you want to say it? It's equivalence class. You
Hmm.
are perfectly aliased or perfectly not aliased. And for things that are not the array, they are generally known to be not aliased directly. So you ask, hey, do these overlap? The answer is they're not aliased directly. A check of
So you
the
get
alias
what, a
number just
separate
says no.
instance of a memory for every malloc point?
You get one for every known thing that you can break apart
Mhm.
according to whatever your strategy for deciding what your aliases are. A standard thing for Java and for C, where no one's cheating on the aliasing, is to say every field and every struct type is different. That is not the only way to do it. That's an obvious one. It also means that you're not doing anything with arrays. So if you have two int arrays and you start doing memcpy questions, the CFNOs here, the equivalence class doesn't help you, not CFNOs. Equivalence class doesn't help you. All int arrays look alike. You have to ask questions about your indices to decide they overlap or they don't. You can say that int arrays are not the same as byte arrays. and that you're guaranteed 4 byte alignment, and that changes how memcpy does its initial checks for alignment. Same for, 8 and 16 byte alignment things, you can tell they're different and know that, memcpy can take shortcuts there. So it doesn't help with, I have two random pointers or indices into two int arrays or 2 byte arrays. Do they overlap? I don't know. That didn't help. If you have a person and you have an animal struct, person.name and animal.name never overlap and they're guaranteed not aliased. And so the random junk field load and field store operations that run through all these programs all get optimized well because you have this great alias info. Hey, this field is never that field. They don't even show up on the memory edges together. You don't even ask the question, do they? Then the question never comes up. You can't
You get
ask
that
that
win
question.
by disallowing certain kinds of casts, or you get that win by just knowing that there weren't any in the program.
Disallowing. You could flip it and say, if you didn't do it, I get it. But if you did a cast, then you have to have a fallback strategy, which says one
Yeah, I'm
add
just
alias
imagining a
flags.
world where you add one cast and the performance characteristics change
Yeah.
dramatically because it just poisons
Well,
everything.
so the easy one there is you writing in Java, and you just can't write that cast. That cast is not allowed. So there's never a question. If you're writing in C code and you nearly don't break the rules, and you do break them somewhere, then the rules have to decide how they're going to behave, giving what is the meaning if I cast a pointer to an int to a pointer? What's the meaning? Well, people come up with, they invent some kind of meaning for it. But the difficulty there is there's no obvious semantic meaning involved. So why not just return 42 and be done? Why do I have to do anything with the optimizer?
Casting a thing to a pointer is, at least to me, seems that it's directly related to memory. Casting to a pointer means
Yeah.
that you have to deal with somehow with memory. C represent them as an address, and from there stems all the problems you can have with memory.
Yeah, you casting anything to a pointer, you automatically pick up whatever the pointer points to as part of the problem.
Hmm. And
So
you have to navigate. You have to have a tools to navigate that memory. So you have to read from address, write from address, and then
you
that
have the tools
becomes.
to work the memory. You just do, yeah, pointer dereferences and you're into the memory. But now the
Mm.
pointer points into your kernel, or the pointer points out
It's,
of your process
yeah,
space, or the pointer
I'm
points.
yeah,
Right, but there's
I'm
different kinds of casts that are different kinds of crazy. When you
I'm
just
Okay.
say this int is a pointer
Yeah.
now,
Yeah.
you're bad. If
Well,
yeah.
you
okay.
say, I have this array of structs of arrays that are contiguous in memory, and now
Yeah.
I want to cast that whole mess to a byte array so that I can just loop over it like a byte array and send it across the network. And then on the
That's
other side, I'm
If
actually
going to suck it
yeah.
in, do
yeah,
some validation,
the
and cast it back.
if
Mhm.
you don't go the reverse direction, it's all good.
I believe you can. Yeah, I'm all for
More or
to
less.
cast it.
So hang on. Let me play devil's advocate here.
Okay.
Suppose I have some code that's setting these structs. You have this array of structs that are dense packed, and I'm
Okay.
setting some fields into the dense struct.
Mhm.
And then I cast you to a byte array, and I begin writing bytes into a network byte buffer. What is the
Mhm.
ordering requirement between the stores to a field and the loads from a byte array? In the standard sort of aliasing class of the world, there is no ordering, and they can be out of order, and you're fucked because you don't get the last write because you grab bytes before the write hit
Mhm.
because you weren't required to order.
Mhm. Mhm. Yeah,
Okay,
but you
well,
explicitly deal with them with raw with memory. I know raw,
well,
but
so now you can come through and say, well, we can fix this by saying if I cast to a byte array, then the source of the cast has to have a volatile like memory fence
Mhm.
from the dest of the cast. And I prevent the writes from bypassing. But that was me extending the declared thing to give you some reasonable semantics. Because otherwise, I'll just write you the test case even in the doc that just breaks. Hey, I cast you a byte array and wrote you. You're broken. You don't get all the bytes. You're dead. Okay.
Mhm.
So, how the hell do you want to do this? Probably. That's a reasonable thing. And what about the reverse? Where the reverse says, hey, I'm going to tell you that I took a network byte array and it's just like a malloc, like a
Mhm.
nude.
but
I want to
but then
convert it
you
into a
but then you
non-alias thing.
You
But
have to deal with casting that, let's say, from array to an object. You have to deal with they
uh,
are contiguous in memory. You have to step over the header class or something, and you have to deal with that in order to
uh,
navigate the array
Yeah,
correctly.
it almost makes me want to have a separate type for struct and layout struct that I know I'm going to
Mm.
care about the layout later.
yeah.
Can you zoom a little bit, Cliff? Mm. Mm.
Probably.
Yep.
How
Yeah.
about that?
Yeah.
And I'm
That's
just
that's
making up some bad thing here
okay.
for my person or whatever. And then I say, oh, I have an S array of 1,000 of these things.
Hmm.
S array S's is this. And then I've initialized it. And then the last thing I did was I said S sub 999 dot age equals 17, followed by cast you to a byte array, a byte pointer of S, right? And then I send you to os.write, something like that, right? This
Hmm.
is this is Aaron's test case here. This write, let me put a comment here. No, I don't. Right? There's no ordering between the writes I do there and the reads. Now I can say OS write is a problem, but I can do this another way and say buff of 0 is equal to byte array of S of, and now I'm reading bytes, 1 here. So let's even replace this with just memcpy. Writing into buff, the source would be SS array buff, and the length will be whatever size of that's something. Okay, so if you inline memcopy, it's just a bunch of loads of bytes. You wrote an int wide thing into some field, and Nary that here 99 is too far out. I'll just write the first struct. Can that write bypass those reads? On without a memory model in place, the answer, of course, is yes. And then you fail to catch the last update to age 17 there. So now you need a memory model that says something about how do I enforce ordering between things that are clearly unrelated. Within the updates to struct S and the array, there's a well-defined thing that says, nary the twain shall meet of all these things, and I can write and read parts, and everyone understands the semantics directly. As soon as I go to memcpy here, what I've missed is there's a byte pointer here. I cast SS to a byte pointer. And I claim that you could fix this problem by claiming that cast has volatile semantics.
Oh, you mean as long as the second you cast it to a byte pointer, it has to be synchronized somehow.
And now you also want to say there are no more writes to memory here, to SS, because what is the
Hmm.
what is the thing that, when is the mem copy complete here? Same thing. He's reading from SS and he's writing to buff. When is it complete? Well, it completes before the next read of buff. But if I came along here and I said, this, and then somewhere down here, there's an os.write buff. There's a guarantee.
Hmm.
Where do you get, what's the semantics here? So Java comes along and says the semantics here are straightforward. You can't cast, neener, neener. So the mem copy question goes away. Then the OS question has a baked into it a volatile like, hey, you had some writes pending. We're going to stall till they're done. And then we'll do IO. And if we have like that goes into a zero copy DMA to direct hardware, like say I'm doing a high frequency trading and that's what I'm trying to do. But I'm a highly efficient OS and I've got this sorted out and it's trying to do good things here.
And
Then
this all
again,
boils down to people rules on the memory node.
Well, if I'm inlining the behavior of everything here, if I'm going to, and then I want to have the volatile, the correct semantics with memcpy being completely inline and exposed in the IR, then yes, there's going to be some IO, going to be some sort of operational memory ops, memory nodes. So you're saying the memory node. Typically, there is a memory node for every individual alias. So what's an alias here? Well, anything to do with the age field is completely unrelated to anything to do with the name field here. So I have at least two aliases. Now I probably have a body alias for array of, kind of depends on how you want to implement the dense packed versus not dense packed. But every write to any age field never overlaps with any write to any name field, or read or write or either direction, which means that when I'm doing things with ages, I don't even know that there's a name array, name alias around memory that's not, the memory pointers for it are completely invisible to me. They're somewhere else in the IR. But when I come to the buff, the mem copy at the buff, I gather up all the aliases that I have for the contents of struct, which might have 99 more fields. And I have to gather them all up, declare them all aliased to this buff thing somehow, and volatile write, all writes have to complete for the IR has to say that. Then I really want to say that you can't go writing into SS again, because it won't be translated into buff reliably. When is the last write into buff show up? So the other option I guess you could do is say, nah, these are, just like Java non-volatile read writes across multiple threads. If one guy writes and the other guy reads and there's no locking, all bets are off. You get random garbage. Now, Java makes sure that the garbage is limited to how junky it gets, but there's no requirement that says, you saw the write to 22 or not. Here, I claim I could fix this by demanding the byte star cast turn into basically a volatile barrier, a read-write barrier. Whereas the second write to age 22, race condition. You see it or you don't. Now Java will demand, and actually most hardware will give you, that you at least get the consistent 4-byte write. There's no byte shearing going on. But there is this, optimizations floating around the universe that say shit like, well, I have 1,000 of these structs. I went ahead and did a dynamic thing and I looked. Nearly all the ages are small or big or whatever. They're all something funny. They're not 4 bytes or 8 bytes long. So I'm going to rewrite them into a 1-byte age field secretly behind your back and give you 1-byte age field and a 4-byte char star, and everything's on 5-byte boundaries. And my array shrunk from 1,000 times 8 to 1,000 times 5. And if you scale up to billions, you can get some real savings. Okay. But now they're not aligned in cache line writes size. So you can get byte sharing.
And the problem, if you cast the directly to byte array, how would you figure out the char name? There could be 5 letters on how
right.
can...
Okay. So then this cast has to have some sort of semantics that say, already you're asking this cast to have semantics that say there is a layout. The layout is part of the language spec, which it is in C. That's what size-up does. It tells you that there is a fixed layout. The compiler knows what the layout is. He'll even tell you at compile time the size of that layout. And then he promises the layout's the same on a future run of the same program, so I can read and write. Now, if I write this on on an x86 and I read it on a UNIVAC 9-bit byte character format thing, which both these guys support C, and the bytes aren't going to line up. It's going to be bad. It's not going to work. I write it on a little Indian. I read it on a big Indian. Again, it's not going to work unless somebody's coming through and the OS has some clue about Indianness and does something about it. So there is already a lack of semantics as soon as I cache it to a byte array, because you are assuming you know what layout means. Now, you're willing to believe the compiler reorganizes the age field and name field. That's very common. we reorganize these fields. We pack the bigger fields up front and the littler fields later, so we get a dense packing of fields, and we take out all the extra spaces. But I mean, if the compiler can prove your age is always a number under, 99, why not go to a byte? Maybe through proves your age is all under, 6 bytes. So he's going to do 6 byte packing. Maybe he discovers that your name field only has ASCII characters and he wants to go to 7-bit packing on the names. Why not? Well, as soon as you say layout as part of the language spec, you deny that because you can do this cast and have it have semantic meaning. It's not a random thing. The thing that happened in old C was this was possible because the compilers didn't get that clever. And when they did, people recognized what happened and they said, okay, and they kind of invented the semantics lazily over time and said, oh, yeah, I guess the compiler can do that. Let's see what we can do to survive
Probably
it.
what you want is for serialized to be
Yes.
a well understood concept, but for
Yes.
layout not be. And
Yes.
now the minute I put a serialized call in there,
Yeah.
the compiler is welcome to say, hey, I know this thing gets serialized eventually.
Yeah.
I'm going to keep driving that backward Henry Milner style
Yeah.
till I get all the way to the initial allocation and say, I'm going to allocate from the first point in
Yeah.
the layout that I know the serialization is going to need way later.
There's another option there, and that is simply the compiler produces this serializing logic for the format of the data it's chosen, right?
But
That's
you have to annotate that.
what am I doing here? Well, by OS. Then,
I mean, like, if I know that I'm going to do CFFI with an object and kind of want to allocate it in that shape already, and if I know I'm going to send it across the network as a thrift serialized object, I should just allocate it as a thrift object and make a view over that thrift object.
So, H2O went over this problem a lot. Here's a data set that has a structure. It's a struct S, int age, car star name, except it had 20 fields. And almost always, many of the fields had very limited domains they lifted over because it was number of cars and zip code you're at and age of person or whatever. But you had trillions of them. And so he compressed the hell out of the data. And so you couldn't go cast it to a byte star because there was no reasonable, presentable byte array format lying around for you to grab. It was all compressed to hell and gone. But there was totally a serializer or deserializer that understood that complicated format and would deserialize for you and reserialize because he had to pass things around the cluster. So of course it passed compressed. So now this is a different thing. It's a different model. Don't start from layout is in the language. If you start from layout, you can do that. You start from layout is in the language, but that hard forces a bunch of things, which maybe is what you need if you're doing embedded systems. But if you're doing like big data, big machine learning, big IO, whatever, don't force data layout. But you do need a serializer. I'll agree with that.
Right. I mean, a good chunk of the value that came out of SQL was that it didn't have a data layout that it forced.
Right. And then
when we went to columnar stores, we just went to columnar stores. The queries didn't change.
That's exactly, that's what HU does. Hey, we're going to make a columnar store out of you. What can we do compressing columnar wise? Well, it turns out you can do a lot. Okay. But now you can't go ask. You can't declare it a byte array, the columnar store a byte array meaningfully. But you can certainly ask for individual elements using the standard accessors and get good performance and get the right things. So yeah, there's something there about speccing the language.
I think if you reject like having a standard like, data layout or a struct layout by default, at least you should have a way of annotating structs to be zero copy serializable. Because I mean, I think serialization is a like nice approach, but still there should be a way of marking structs as just being plain old data types with no padding bytes, dense things that I can just like basically cast.
You're asking for a data layout in one breath, and in the second breath, you're asking for an efficient serialization format. But I'm telling you that those are direct in conflict, and H2O made giant hay out of having them not be the same.
No, I'm talking about like zero copy serialization.
That's right.
So
That's right.
yeah,
The
and that's not
access patterns that you got out of H2O looked like array lookups of a two-dimensional array of structs. The actual underlying layout could have been run length encoded. Give me the 17th element. Well, I have to go walk the run length encoding to go count. There is no direct go get this thing as an array element and like do it. Hey, I want to write to it. Well, I'll repack the run length encoding and change its layout dynamically as you rewrite into it. There was no, it was just this layout of bytes, and then I replicated it a million times. No, every 10,000, 100,000 rows, we retried the compression logic because the data sets varied over time. And the same column of ages might have this kind of layout in one piece of the column and that kind of layout in another piece of the column. That was actually quite common. There were like rare Booleans that would be true sometimes or false sometimes, but mostly the other way. And you would take, well, 100,000 in a row, I'll just, do the whole chunk as it's a constant true or a constant false. But if you missed and got a different chunk, I'd have to ask that chunk, how are you compressed? And then he would say, oh, I'm a bit array. I'm a run length encoded array because only one bit in 1,000 is set. So I just give you offsets to the next set bit. I'm
That
just saying, don't
does make me
say
wonder if there's value in a language having a data layouter in the same way that you have a garbage collector.
that
That
there is a data layout for every embedded thing that is useful. If I'm
right,
talking to
but
hardware and it's memory mapped, data layout makes a lot of sense.
so if I'm imagining a world where I got this big array and I colomerized it and it's hard to write to any one value.
You make a function call to write to a value, and then
Right.
the
So,
function call asks that compression strategy, please update, and that might change the strategy, and it might just be a straight up it went in. Suppose I decided that
This,
your age fits in,
right. But you could totally imagine something where all of my writes are going to some look aside table.
and the H2O did
Here's
that
a
as
hash
well.
table that's got all the writes
Yeah,
that happen.
yeah,
And
H2O did
then
that as well.
periodically, in the same way that the garbage collector runs,
Yeah,
some compactor comes around and says, hey,
yep,
there's a bunch of stuff in this table. I'm going to go merge it all back in and then
right.
under the hood, swap it out for you.
That
Oh,
eight,
you parsed something across the wire and you
yeah,
kept a bunch of slices into the string. Well, now you're holding on to this 10 megabyte blob because you need 8 bytes from the middle of it that's a string you're holding on to.
right.
Well, the data compactor comes by at some point and says, oh, I notice you're holding onto this big thing because you only need a tiny slice of it. Let me copy that tiny slice
Yeah.
and free the rest of it. You could totally imagine, particularly for a long running system, that you get a lot of hay out of a compactor that is just running
H2O
around.
totally did that. If you could fit a store into the existing structure, it went. And if you could not, it unpacked into your fat format, took the write into the fat format, and then periodically the compressor came around and shrunk it again. And
did you write how the data is compressed along with the array? So
yeah,
how?
yeah.
Hmm.
We had about 20 different compression strategies.
And you wrote them in the byte arrays, and then so essentially this was a wire format, a wire.
This was the in-memory storage format. The rules we went with was that it was always fairly cheap to get an individual. Well, the main rule was you could read it compressed and decompress it in a few clock cycles per element into machine registers. So it never passed through the memory hierarchy or the networking bus decompressed. It was always compressed going in and out of the memory hierarchy. That was rule number one. So that was your efficiency. That's your speed. You have way more clock cycles than you get memory bandwidth. Don't burn bandwidth pulling uncompressed fat bits through the memory bandwidth. So now when it hits the registers, decompress.
You say uncompressed into a register. So
Yeah.
all of the data has to fit.
You said all, but no, you would uncompressed element by element, but in a rolling forward through linear time. So the decompression strategy was always, I'm going to be completely the most efficient if I'm single stride line access rolling from end to end, which was the usual pattern for doing visit all nodes and do big data math. If you grabbed a random element and it was a run length encoding, you took some time to work your way through to find the element in question. But if it was like, I just use 4 bits instead of 64 bits, then every new element was the next 4 bits. And somewhere I told, the C2 JIT, grab a byte, masked 4 bits, and he took that loop when he unrolled it and said, grab the byte, first bits, second bits. Then he unrolled it again, said, grab a 16, grab a 64, big old unrolled loop, and he was grabbing and shifting, masking bits off. And I didn't write that code. I just wrote, give me 4 bits. But the strategy in that case would have been every element is 4 bits. And like I said, there's about 20 strategies with variations inside of each strategy as well. And the design point is only read compressed data.
How do you keep your live range small enough that you know you're not spilling to main memory?
Well, there's
Like,
no.
it sounds like when you say only registers, it probably means
Yeah.
only L1.
Yeah. So you didn't. So the user wrote an inner loop that was as big or small as the inner loop was going to be. And you would love the inner loop to only ever work out of iCache, never run out of iCache. And then the data set he was running on was generally swept through. None of that ever is going to fit in your L1 in the whole, because it's always max size of the machine. So it's always gigabytes, terabytes. But you're going to stream it. And so the streaming prefetch wants to prefetch the compressed data. And then when you decompress, you need a couple machine ops and a couple registers. And sometimes that had spill code. So it wasn't spill to main memory. It was spill to stack on an x86, which, it's not quite as cheap as a register, but he goes to great lengths to verify that, make that shit fast. So you ran out of registers, you did, but so does anyone else on the planet run out of registers. So the array math was a little more complicated and it needed a few more registers. But that was the limit, just needed a few more. There were a few cases where it was a little more gruesome. Like the usual story on strings was we literally just ran gzip and left them gzipped. And we had an index into the gzip buffers to go pull the compressed bits out. But if you wanted to start really fiddling with strings, you were going to go unpack all the strings and have string data and do string things. And that was just going to eat up the time. And people did occasionally. And there's no win there because it wasn't column or relay strings of various kinds. But if it was strings that were fixed and read only, we interned them, turned them into an index into an interned hash table. And that was back to being small, dense integer values. So you could filter.
Yeah, columnar for strings is surprisingly weird because it's not that uncommon that you run into a place where the first 22 bytes of the strings are all identical and the last 4 bytes of the strings are all identical.
.com.
And then there's these 7 bytes in the middle that are
Yes.
always identical. And then you've got 2 wildcards in it.
So
and you're like, I want to pull out just these 2 wildcard pieces, but oh my God.
So the old school version of this is, what is your city state kind of thing address? And there's huge redundancies. And so interning makes total sense. And then go ask the question, hey, I want to send a mailing list to everyone who lives in San Francisco as opposed to LA, for instance. Well, okay, that's a sweep over a billion people, but checking 1 byte to see if it's the San Francisco index instead of the LA index. Easy. You're doing URLs, yeah, you got a mess. 22 leading HTTP : / www dot whatever, oracle.com / blah, 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 blah. And then the 7 bits in the middle that are different. And then .. /.com or something. I don't know. Yeah, you get.
But I've seen people play games with a string that was a byte indicating whether it was one of the 255 most common prefixes or not. A byte that said whether it was one of the most 255 most common suffixes or not, and then the middle.
We just went to
that's a
gzip
mess.
if it wasn't obvious. And that's because we weren't trying to optimize. We were doing math, and the strings were generally not part of the math. They would be, as I want to say, a factor or a label or whatever. Like do math on give me a regression on who lives where. Well, one of the parts is who lives where and what's your average salary or whatever I'm going to do with the regression here, and matters San Francisco from Tennessee. So those would show up as fields in the regression, but not as San Francisco, the string, but as just the enum that meant San Francisco. Enum is what I was looking for. That's the field for that one. Oh, getting back to this thing here on what to do with C code. So I claim there's a in between Java and C. It's if you have structs and classes and things like that, and they have fields, and you don't do casting, you can get away with this really strong for free alias analysis by doing this equivalence class thing. And if you throw serialization in, like you teach the compiler that it's serialization, you get right back to the compiler can restructure the data layout any way it likes, preserve the good semantics, and give you reasonably, get you more efficient layouts than what, people were saying here, where I just picked a fixed layout for all. And still all have good semantics for smashing it down. And then separately, there's and I want to pick the layout because I have an embedded system and I just need the layout for hooking into machine code or writing to the hardware for doing networking IO or whatever the hell I need. I need a layout.
Yeah, I mean, if I want to do a syscall, I often have to lay out that data very specifically.
Yeah, a syscall would have a layout. Yes. Actually, that's a really strong, that's a good argument. That's like I'm about to make a write call and I want to say, I'm going to fill up. Here is a series of buffers to go right, and here's a count of buffers and the length and start, da 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 da, whatever the thing is going to be. Well, that thing is going to be picked up by the OS, who's going to have a fixed known layout because it's the same for all functions, all callers into the OS. But we don't have a serialize, deserialize semantics nailed really well, like a user written serial, deserial semantics laid out such that I can do a translation from a network byte buffer array into a well-typed thing without having aliasing issues, unless I throw something in the language. So I said in my memcpy, I said byte, but the serializer wants to do something almost equivalent, more clever on how it serializes, but he basically wants to say, the output here, let me change standard out to output buffer. And then, what's the relationship between, so Adrian was saying, I want a zero copy, so I want this to be the same. And as long as you don't ask me what the layout is, I can leave output buffer and SS be the same memory if you don't write to SS after I do the serialize. And the reverse guy, somewhere in the universe, wants to know that his layout is the same as well. So the serialize, so in H2O, the serializer hack, one of the serializer hacks is he only talked to other nodes in the cluster. And at startup, the nodes in the cluster agreed how to serialize things. So they came up with a hidden, we're not going to tell you what it is, serialization strategy that they exchanged amongst themselves, made the argument they knew. So now if I serialized it the H2O way, another H2O node could reverse it with essentially the 0 byte copy that Adrian's looking for. But it wouldn't be persistent over time. As soon as I go persistent over time, then I have to have a known fixed layout. I have a known fixed layout. I have a fixed layout. I better make it known. So that's the 0 copy versus 1. If I do 1 copy here, Adrian, I have a defensive copy made. I can hack SS right here. SS sub 0.age equals 22 is okay because defensive copy. And that means that the output, which did all kinds of weird things and made a pile of bytes, but it compressed the shit out of them. I'm not actually stomping my pile of bytes. I'm stomping my age, however that was done. Like, I don't tell you what the layout for struct is, struct S, array of struct S, and I don't tell you what the layout for output buffer is, except that I promise you that the output buffer layout is efficient for over the network, and that the struct S layout is efficient to read and write individual fields. So, okay, fine. Is there something else to be said here about, now, promise me 0 copy? Well, if I promise you 0 copy, I have to have both at the same time. And I can assure you that I can arrange for a data set for struct SS for which that was a bad choice. Here's a trillion struct SS's, all their ages and all their names are always 0. There is a really efficient network version of this. There's a really efficient never write it version of this. where it's just always a 0. So there, there's runtime stuff here. Oh, we done with this? I'm trying to think if there's some other thing to say about it.
Yeah,
There's
no. Oh, go ahead.
there's something actually I found interesting. So I think one problem of doing these bytecasts is that you lose type information. So like you're looking at the byte buffer and you don't know what's behind it. So you don't carry around the type, you don't carry around
Ah,
potentially other things. And there is like I've seen proposals to add, for instance, raw memory, like typed raw memory as an actual data type in the language. So
nice.
yeah, it just refers to a piece of memory that's typed, and so something like memcpy is not something that takes just a pointer, but rather memcpy is a generic function which takes a type, takes data, and then like does something with it. So you don't have to abuse like char pointer
It's
to
because
do
you're
all
looking at
kinds of things.
like Java has clone, which takes a typed object, a pointer to a typed object, and gives you another pointer to a typed object. And he mem copies under the hood, but you don't write mem copy or system.array copy. You call clone, you get a mem copy effect, but it's totally typed input and output.
Yeah, that also works. Yeah, I'm thinking of what is the benefit of. Yeah, I mean, I guess you can. I mean, you always have the option to do type pointers. Yeah, I
Um,
think this
um,
is possibly like beneficial for like low-level IRs to have something like a universal data holder that still carries around type information. Like, yeah,
right, right.
Yeah, I would almost want to express that as both places get a slice, but one place has a byte array slice over a union of byte array struct array, and the other one has a struct array slice over a union of byte array slice array,
Well, the reason to have byte
and that the
arrays, you
type
want
was a slice over a union.
so why do you need a byte array?
me?
I mean,
Why did anyone
most of the times I have done anything like this, it was just to serialize stuff and throw it across.
Yeah, right. That's what I'm trying to come around to. Why is there ever this desire to move you to a byte array type or out of a byte array type? It's because you're serializing. You're going on wire. You're running a
I
disk.
mean, I should say that slightly differently because doing security stuff, it was often that I was pretending to serialize to send a thing across the network, and actually I was buffer overflowing in order to break somebody. But that's not really a good use case.
Yeah, I'm claiming that one should be fixed by not having by range checks, and then you don't get any buffer overflows.
I mean, I would rather that just not be possible and not have
Yeah,
to do it and not have to put it in the report.
right. What I was trying to come around to was can we get away with no casting to and from byte array because you do that to do networking, to do IO, and instead you carry the sharp types all the way through, and only at the lowest possible level, at OS level, does he like say, I'm about to hit the hardware with these bits. Okay, then I don't care what type you are. I'm just going to pass you a pile of bytes. But the receiver will be told what pile of bytes he has to know what pile of bytes he's going to get. Somebody will check you and confirm you're getting the same pile of bytes. I mean, that's one of the serialization formats. Like Java bytecodes have verifiers because somebody says it's really a valid pile of Java bytes, except I wrote, hacky shit. So you have to have a verifier there. And then you pull it up on the other side as a verifiable pile of bytes, as a pile of structs. Right? Now, if somebody hacks you in the middle, then your structs, don't have the same data, but at least they look struct-like. Your security guy still has work to do.
Yeah, I mean, there's some software out there in the world that does funny things when you have an enum that's not one of the enum numbers because you casted that enum from an int.
Right.
You're like, well,
You
you got what you deserved.
didn't verify, didn't get what you asked for, didn't verify either, so now you're in trouble. I guess the other thing I was looking at here was wrapping a serialized type around another type, and then claiming that the type of output buffer is a serialized version, and given a serialized version, I can then OS write it. I serialize it. So it's not OS serialized, but I serialize it and then I write it. And then that includes, maybe you can imagine that would include the type of the thing so that when the deserializer guy happens, he'll tell you what type you're getting out. And if you're strongly typed, you tell him you agree that on the same type. There's something useful here. Looks like there ought to be something useful.
Yeah, including that type is
Yeah,
useful.
requirement that the unpack has a strongly typed result
Yeah.
and he will blow at you.
That's all the serializers problems here. Jackson would allow you to serialize for a base class instead of for a particular instance, and you could see all kinds of things you are not meant to see there. So GraphQL gets around that by including the type field, and you know exactly what's the target type you need to be
Yeah.
deserialized.
Yes, surely JSON has sorted this out a long time ago.
So Jackson has security issues like that because you don't know the target to which is you are serializing. So instead of the target, you deserialize to a base class, not on the particular instance, and from that you can get all kind of troublesome things.
The concept here is just like Java bytecodes. You could certainly have verifiable data sets that had some sort of type info that could be checked by the caller, should be checked by the caller that they match within the semantics of the type info would allow.
But you have to include that. But you have to include the target
it has to be
type.
included in the data.
Yeah, that's what GraphQL is doing. GraphQL will send you the type field to
What
which
was
is
it called? GraphQL?
GraphQL, the format. It's like yeah.
Throw a link in.
So it's like a JSON, but it's more flexible. You define the output format.
GraphQL?
GraphQL. Yes.
There you go.
Yeah.
Sounds like something worth looking at.
Yeah, but it has its problems, of course.
Yeah, I'm sure.
It's, I don't know. Is it good? Is it bad? It's a matter of taste.
I did a bunch of stuff with Jackson in prior life.
Yeah.
Oh, faster ML, Jackson's almost surely that way.
Jackson security.
One of these is going to be Jackson's been around the block so many times.
Yes.
Grabbing a random Jackson thing, I don't think it's the good one.
Yeah. Okay. Cool. Yeah. Okay. Next topic, maybe.
Yeah.
So what happened with simple chapter 16 is in chapter 16?
Chapter 16, I thought I read it last week. It was the constructors are in. Finalizer constructors.
So the function chapter, where is
I
it?
just threw the hollow shell chapter 17 out. There's nothing in it.
Okay.
So chapter 16 is the last chapter completed. And I have life to do and other people have life to do. So I haven't looked at 17 yet. Although here you go. I mean, if I do only forward flow typing info, I could do a bunch of things that would impact simple all over the map that are sort of straightforward here. So I'm really thinking I'm going to head for AA style things. So I'm going to say var function. So var, I can do var of any kind. X is equal to 33. Well, I look at the type of the right-hand side and I can tell you the type of X. So that's standard forward flow typing. Take the expression on the right, that's the thing on the left. Functions bust that because they get recursive on you and they do all kinds of other things. But it's a normal variable. And now you have to have defined your arguments. So I have to have int x, int y, and then I'm going to turn you to, math.squared of x times x plus y times y. Something like that. See, H2O simple doesn't allow you to convert floats to ints. Oh, I think I have a 2 round or something. There might be a round call. Truncate. I can get one, make an integer to integer thing, but I can also just do this float style. Ooh. Oh, look at that. Let's try again here. No. Oh, interesting. Okay. One of the buttons converted Google's doc scaling, and one of them converted Firefox scaling, and therefore, near the twain shall meet. So this style, where you say open curly is a function header. You have arguments with types in the regular typing way. Arrow body, which is anything you want. And we could demand a return, or we could just say last expression and drop the return keyword altogether. That would be a function. And then from there, you could go to embedded things where I have, U8 array is a name. I don't have strings yet, but I can get there. And int is, max portion of the name or so, I don't care, whatever thing. And then somewhere in here, I said, var function. And now I want to say, I'm going to get a directly available in the namespace struct s. I have a this pointer baked into me. So I could say, print name or whatever, because inside the function body, he gets the full namespace of the surrounding context, and it becomes an instance method. So I can't call function. I have to have an S. So somewhere in the world, I say new S, and name is equal to ABC, and then I can call function on it as a no-arg function, and that's an instance method. So that's kind of the thing I'm thinking I'm going to be headed for. And then I think other things will fall out of there straight up here. And I would still like to have trinary, which I should probably just put in here.
Your var is basically just like auto.
Yeah, auto. Yeah, but it depends on whether your Java var is auto and C or something. Yeah.
Do you have a const that is distinct from the var or not really?
No. I do. I actually, now that you said that, I have a bang, which means you cannot modify. Bang means this field is final. It must be followed by an initializing set, and it's done. So if I put a
So
bang
const
here,
would be spelled bang var.
it would be var bang, because you can have commas that don't have to have independently final. Like finals on the variable, not on the type. On the variable name and not on the type. So if var x y is equal to 44, but I can put a bang here, meaning I can update x but not y. It was just syntactically easy. My theory is if you're writing bangs to mean final, you don't write them very often. And you write them one on a line because you must put an initializer. So in the case of the struct s here, the bang here doesn't have an initializer, but when I say new, I then must put in an initializer for name. And it's actually curly because this is an arbitrary expression as alongside initialized name.
So here only functions, no closures. Can I
But no
refer
true
to some?
closures. So I'm not going to do true closures because I don't want to deal with the runtime implementations things. And the strong typing means because I know the type of X, I can compute the type of factorial as int times and a 1 and a trinary of an int times and an int. So I know it's an int, and I can deduce the type of fact without doing Hindley-Milner here. I believe I can deduce the type of fact without doing Hindley-Milner here. And this will just be a function that takes an int to an int. Whereas this guy will be a function that takes an S struct and no other arguments, but you could have other arguments if you wanted to, in and to whatever it's going to do.
So right now, the CF nodes has all the necessary construct to support functions. So
the simple version doesn't have a function in it yet, but that's not a huge thing to add. You need an application and a function definition. You need a lambda and an apply, a call and a function header.
A lambda would be represented in the CF node as a lambda node.
Yeah, lambda node. Yeah.
Okay.
And the slight distinction here is I usually declare I have a, well, we can go back and forth there. What I do with the AA is I have a function pointer, which gives you a compile time constant pointer address of the function. Yeah, it's going to turn
It's
into
like
a number.
it's like a C function pointer.
Yeah, it's like a
or-
C function pointer, so it's no closure.
Yeah.
Um, and then there's a function header, but the lambda actually goes with the function pointer tail. And the header is nothing more than a hook place to start when I do codegen, but also if I do inlining, it's where you stitch the arguments in to do the inlining piece of things. So there's a fairly straightforward translation here, but what you would consider a lambda from the lambda calculus would be, I would call a function pointer because I'm not doing real closures.
Okay.
And then namespace issues.
So a function pointer function wouldn't have this pointer. Is it like an
Wouldn't have this.
object?
I'm sorry.
Is it like a function would be an a class or instance or object, or it will be directly
A function.
At least in my head, the difference between function and closure is the closure's got a self pointer.
It has an environment pointer.
it has to have the capture. You
It has
have
to
to
capture to an environment, which might be a large, complicated thing. It's
Yeah.
all your prior stack frames, and a function does not.
Mhm.
So here I'm going to fake a closure by saying I have a this pointer. It's not really a closure.
Mhm.
And I get you a hidden extra this argument.
Mhm.
And if you nest structs that this argument has to be able to point uphill, I have to do some, actually, yeah, I probably have to start working on that one. I don't have to do that yet. So there's work to be done to do this kind of a style, to do the,
Yeah, the first jump would be the function pointer implementation.
yeah, this
Yeah,
one, well, this one is easy
Mhm.
because there's no self-reference.
Yeah.
Here,
then-
I claim I can do this without Hindley-Milner in the sea of nodes, but I need to screw around with the self-reference. Then you get I have mutual self-references. And then otherwise you call it is odd of x minus 1, right?
Mhm. Yeah. If you demand the function type, the arguments of the function to be type, I believe you can go far away without Hindley-Milner.
Yeah, because the arguments are typed,
Yeah.
you always have a starting point to propagate forwards. Like
Yeah.
if I start parsing this, I have fact, it doesn't have a declaration yet, so I don't know what it means. I'm holding on to it in the parser without any meaning to it.
This
Then I
would
see a
be
function,
yeah.
and then I see a function takes an int. Then I come through here and I see fact. Okay, I don't know what fact is.
Mm.
Now what I do? Oh, I declare you a forward reference, but I don't support that unless it's a forward reference of a function. So I don't know what it returns. So then I do times x here. Well, if actually in simple right now, fact returns a float, I'll widen this expression, get you a float out of it.
Mm.
So I might be in trouble. It might be that I can't quite do this here.
Why
It
can't
might
you
man-
deduce? What can you deduce? So the x is designated as an int here. Why
Yeah.
can
X
why
is
why
an-
should switch type? Why should switch the type? So
Well,
I
yeah,
was going to say, aren't you unifying? Doesn't the right and left half of the colon have to have the same type?
of
yeah,
course
but the
they-
normal rule here is to say if they don't, it's an error.
Mhm.
But the problem here is I want to say I don't know, and then that nowhere in simple do I have an I don't know. Right? I do have some forward ref notions that I pinned and hang on to, and you're not allowed to make a new of them. You're not allowed to do like 3 or 4 things you can't do anything with until you get a declaration, and then you can. And then inside of them, inside the parser, he actually does secretly, no one knows. It's well documented, but no one knows. He does a union find
Hmm.
to say, oh, this one type is that one type over there. Okay, I'll union them together now and get away with it. Okay. But yeah, like doing the is odd and is even gets away from the, well, I have it fact here and I have it here. So go to this, right? And then say, well, now I parse is odd. What the hell is is odd? It had nothing to do with is odd. Like the parser has no clue what is odd returns. Now you could argue what, Aaron, what you say is that since there's this trinary and he has an I don't know and he has a true, the end result must be true. And in fact, I think that's pretty much what I do with the futures. I could declare them top. To me, that works. And then top and true is Boolean, and then the answer is Boolean. Okay, so is even is Boolean. And now when I do the is odd guy, is even returns a Boolean, and it's all good. So I think that's actually going to work. That might work.
I mean, you may get contradictions that are somewhere far away from where the actual problem is in a bad error message, but if it's correct, it should work.
Yeah.
I just don't know if it's wrong, you'll get an error message that's easy to debug.
Yeah, I'm not allowing var here. Okay, what's the type of this function? Well, it's var. It's the
No. You should disallow that. So var it doesn't have a type, so it has to be ID polymorphic here.
It'd be polymorphic. I'm not supporting polymorphism, so I'm going to disallow this. Okay, now what's the type of this function? Well, if I declare id here being a forward reference of a top, but I know x is an int, this is a function that takes an int, returns an int, and oh look, that works. So I'm all good as long as you don't have var on function headers, function arguments.
Yeah.
So the error message is just that things flow forward, and if you get to the end and there's still any tops in your sea of nodes, you just don't compile. You say, hey, dude, you've still got a free variable.
Yeah, well, you still have an undefined variable. Yes. That one gets caught directly, but I think I can have like this var id case where I had a var here would show up as the type of this is a function from top to top, and then I would throw an error at you and say not well defined. Whereas if you simply don't mention a variable, when the scope ends, I blow up on you. Now I could improve that in saying, as long as there's an outer scope where it can be usefully defined, I'll let you be forward references all the way out to the top. And then I'll count them all and say, you never defined this. Okay, wait a second, dude. And then blow you out with a nice polite partial error message. So you can look at the is even, is odd case and make a version of that where he breaks because he has another scope. So he defines...
one question. How would the parser would know that he is inside the function for the open curly here?
Yeah, open curly. Yeah, it's not ambiguous.
So open curly, list of arguments, the arrow, and the arrow designates the body. So typically in an abstract syntax tree, there is the function, there is the body of the function, and then return type. How would you represent them in a sea of nodes? Only one node, which is called a function, and
so when you parse the var, like suppose I allow parsing var as a separate step. The reason I say parsing var is because otherwise you have to put a type on the left-hand side, and function types get big. If you want to have a function somewhere and you're going to do any amount of type inference on the name, I don't really want it like if I'm doing C-style Java name, so I'm doing factorial. Suppose I'm doing this in C. Well, I don't have var for this. I have to actually write a function type. So I'm doing that simple style. The type comes on the left. What's the type? Well, type is this, arrow, int. That's my type. Factorial is equal to ... the above expression. But I have to write this open curly int, arrow int, close curly for fact. As functions get big or common, you have a lot of them. That sounds like a lot of grief. So I was voting for var, and then as soon as I have var gets used in a bunch of places. So there's a type parser. The type parser says, I know a type should be here. Open curly becomes a valid type, start of a valid type. And he parses some amount of types and commas and types until he hits an arrow, and then he parses one more type and a close curly, and anything else is not a type, and then the parser is not ambiguous. It's all good. And when I come down to this kind of thing, where the is even here, I have a variable, is a variable name, identifier equals, well, as soon as I see an open curly, I'm going to say it's a function. Now I'm into the parsing of a function header, and then the function body and all that. So this is not ambiguous from the parser's point of view. Neither is question mark colon, both of which could be thrown in along with var as a widening of the allowed syntax before hitting parsing function bodies and then implementing them and such. We'll see.
Okay.
So yeah, I got straight up. What was I trying to do? Oh, you're trying to do forward references out of scope for references. Somebody puts a scope here. They even call is even. And they're doing something up here, and int res, and they're trying to do something, and this is if foo, I don't care. Well, is even calls out for is odd. Now, is that a forward reference, or do I let you go? Or do I declare a forward reference, you're dead? Right now, my theory is I'm going to say forward reference, you're dead. If you're side by side in the same scope, is even is odd in the same scope, I'll let that go and say, okay, I'll find the other version. I'll find you at the same scope level. But if you're in a nested inner scope and you are afterward not defined at that point, I'm gonna blow up on you and otherwise claim just move his odd up earlier and now you're good. This one's good and the other one is bad. Because then I don't have to deal with forward references forever and a day. I'll end up all your forward references at the end of a scope. And what I do in AA was I took forward references that were not defined when the scope ended, and I promoted them to be a forward reference in the next outer scope, which would work here. I would find the is odd. Okay, you're a forward reference. I got you. It's all good.
Is there a difference between forward reference and top?
In simple, no. But there is, but I mean, one's a semantic, one's an identifier in the parser that's not declared yet, and one's a type. By using top as the type of a forward reference, it implies nothing on how it is used. So that later when the forward reference becomes declared, it can be declared as anything, and it has not constrained anything at all. Now, as soon as I do a forward reference like is even is odd here, when I get to is odd, and I say you're a forward reference, I'm going to give you as top, I don't know. Then I see open curly, you must be a function forward reference because that's the only thing that's valid in this context.
So I was thinking about like in awk scripts that I write.
Uh-huh.
You can just be like x equals x plus 1, even though x has never been defined anywhere.
Yeah.
Because it can tell from the plus 1 that what you mean is a number.
Yeah. And then you get the default.
Number has a default, which is 0.
0. Yeah. Yeah.
So the first time you hit x equals x plus 1 with an undefined x, you just get back 1.
Yeah. Yeah.
You could do a more general version of that and say, hey, I ran across an undefined forward reference, but I could tell by the time I was done doing all of my type analysis that it is in fact a instance of this particular class, and that class implements the default constructor. So I'm just going to call the default constructor and get that behavior in your language of any time that there's a undefined reference just sort of appearing in the middle of a, a dot append whatever. Oh, I can tell from what's happening later that A is a list.
Simple
the default constructor is the empty list.
Goes with this model that he's doing essentially one pass over parsing. He never revisits.
Yeah, this is more relevant to AA, I think, than it is to
AA is the same thing. One pass and never revisits. And so
I like that.
Sorry, what, Adrian?
I say I like that. That's exactly how I do it in my language.
So now if I have a forward reference, what do I do with the never revisit theory? So in AA, if I see a forward reference, I declare that the only forward reference of interest is a function. And therefore it has I don't need its value immediately because it's not being evaluated immediately. And so instead of evaluating it, I'm going to put a function pointer top specifically in for AA. And then later when the function pointer top is found, I have a people that just matches it up. I mean, I do the name lookup. It's currently defined is odd becomes currently defined as a forward reference function pointer. I have a declaration. It better be a function pointer. I unify the two. Since it's a top function pointer, it always unifies for free. I say unify. do a meat. The meat is for free instantly. It's the whatever value it is. And then I replace it in the graph with a standard peephole, and you go on. You built the graph, and the only going backwards is the one node that was the forward reference got replaced with the actual reference. If you do that for other computations, I think you get weird quick because functions can be delayed and other things are not. Right. So if I say,
But I could certainly imagine a loop that starts with append to the output one of the values.
yeah, so your X case is maybe a little
That's why I reached for the x equals x plus 1. I assume I'm doing some kind of, total equals total plus value at the beginning of a loop.
here I'm trying to be evil all the way around here. Where out is a number or a string. Am I concatenating a list of numbers onto a string array, or am I adding up a pile of numbers? I claim here I'm not defined because plus equals works for strings. I plus plus only works for integers.
Yeah, I was going to say your I plus plus defined it.
Yeah.
Might I? Because the plus plus declares you have to support a plus one, int plus one. I'll declare you an integer. Fine. But it didn't say anything about out. What is out?
I mean, doesn't out have to be an integer because it's a
Why can't
sum
it
of
be a
integers?
string?
Because what is in string plus an integer?
Well, awk and JavaScript and Java all define it.
JavaScript, that sounds like a JavaScript. It's a no. It's a no.
This is well defined in Java, and I want to say JavaScript, and I know other languages as well. Right? I can either print, whatever 1 to 10 plus 17 is, whatever 70 or whatever number, or I could say some numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all.
Doesn't plus
I mean,
equals
do you have a terminal?
for
Should we
string
go
demand?
write the awk and see what it does?
Oh, and
Okay.
then, we're trying to define semantics for simple. Can we get away with inferring at first use?
Doesn't plus equals here demands for I to be a character?
No, it can be. You are correct that the string will take a plus equal car in some languages, but in this case, the plus plus on I demands I as an integer.
And it can figure out that this is a string and to append the
Well, how does it? That's what we're trying to come up with. So let me make it a little more clear here. First use of out is right here as part of a plus operator. Okay, which one of these two outs is the correct one? I claim they're both legit. They both print something different.
That would require the plus for the string to be overloaded.
Or 70 something. I don't know, whatever the number is. Right. Both of these are, so I'm claiming this is ambiguous. This program is ambiguous as written if you allow strings to add, which many languages say string plus two stringable thing is a concatenation.
Okay. Okay.
Yeah, you land in a terrible binding affinity game.
Well, this just goes into, Hindley Milner even can sort this out in some situations, but in this case, I claim it's really ambiguous. And no sorting is
Here
possible.
you're correct. For Java, you have to have a toString here.
No, you don't have to. That's the whole trick. Java will
no have to. It will automatically because object has a toString. So
you'll get a toString for you. That's correct. If he thinks out is a string. So in the land
out is an unknown.
He doesn't allow that. See, in Java,
then plus one plus integer should just make out an integer.
As soon as you say var,
even though string would have been fine and float would have been fine and probably big int and complex would have been fine.
Yeah, float works too.
And
Okay.
big int and complex
Right, bunch
and
of things.
rational.
Yes. I don't know if big int takes the plus as a thing. I'm not sure if that one gets done in Java. I mean, so if you say var, you have to have an initializer. You must have an equals, and then you get typed based on the right-hand side expression, which can't mention var because that's a forward reference. So it works to put var down, but you put a declaration down. Well, any of these work because they all have declaration on them. So anything here works, but if I put nothing down and just say pick var out of the blue, I claim ambiguous. Can't pick var out of the blue.
Mm.
But I think that's an okay thing. Your aux example of I just said x plus
Well,
one works for that one.
if you say var out, so
Yeah.
at this point the type would be defined. What you put here.
By the dot 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 you highlighted. That's correct.
So
Because it's defined there and he doesn't include out. There's no self-reference. It's deterministic based on the prior part of the program. That's all forward flow typing. That's all great. That one works.
Yeah.
Any one of those four choices all work, but none of them does not work. You must have one of them. I can't guess which out you meant there. Or I see no way to guess what the value of out is there. As Aaron said, hey, big integer, complex, wait, there's more. Yeah, there a lot of things can go there. Fine.
Okay.
All right. Done.
Yeah. Next topic.
So yeah, simple's not going to go there. But I might do the var thing to save me some writing. I'll write my first functions without var, and maybe I'll add var later. I'm badly needing some simple syntax, some syntactic sugar in simple. Var would be one of them, but so would question mark colon, and so would plus plus. The combination question mark colon plus plus would take most of our large examples and cut their volume of text by like in half, like a huge reduction.
What platform are you targeting with simple?
Oh, I'll do code generation probably for x86 because I have one in my face.
x86 Windows, x86 Linux.
I kind of don't care. I'll throw bits in a buffer and then I'll ask somebody what's the easy way to spit out. I'll probably have it cross-compile a Windows like exe. Both of them are pretty simple, and then a a.out, whatever Linux format. Yeah, I mean the part where you go from a pile of bytes to an exe thing is a thing I'm going to ask somebody else, and I'm going to get handed a library, and I'm going to.
Yeah, I mean, I was thinking about the sort of educational value of a chapter on how to do syscalls.
Well, that's different than, oh, I see. Yeah, I wasn't doing
But that's going to be very operating system specific on where you ended up.
I wasn't
I
going
mean,
to do
some operating systems you don't even have like syscalls are not even always the actual abstraction layer, like the stable interface.
Yeah.
Sometimes it's a C library, so
C
you
library.
need FFI anyways.
Yeah. In a lot of people, it's a C library, right? So that means that I will probably produce a .o and need to be linked against libc. Possibly, because the other option, of course, it's Java. I could totally put bytes in a buffer and make a native wrapped call, and execute them bytes.
Why not to a class file? To a class,
you don't mean
execute
bit code. You actually mean execute x86 bytes.
Not byte codes. That's correct. I could emit byte codes as a class file, do class for name, just what Theodore said. But I could emit bits in a buffer and call a native wrapper to go execute those bits.
That's more interesting to me.
I'm sorry. Yeah, and then the other good thing about spitting out a .o at least is that we put it up with Godbolt next to Clang. And you say, oh, look, Simple did this and Clang did that. Oh, this one sucks. That one sucks. Oh, why don't you do this optimization, that optimization? Oh, wow. Fine. There's a lot of education benefit to throw it in a .o and then compare to what Clang does, for instance.
So chapter 17 would start a function as a function pointers, and it will leave there. It won't go to closures. It won't go to...
No, not going to do closures. I mean, we could argue if somebody gets really excited about closures, we can have a discussion about what it takes and why. I wasn't going to do Henley Milner, and I wasn't going to do closures. I was going to claim them beyond the scope of this tutorial. the original tutorial was sea of nodes. We could go to adding cogen. I have just recently redone a cogen for a bizarre set of chips and register allocation and instruction selection, all that. So it's all fresh in my head. I could certainly do x86 cogen. If somebody had another chip that they could run and test side by side, like a RISC-V or an ARM, I could do that. Do two
Honestly,
cogens side
for
by
the
side.
purposes of education, I mean, if you have functions, if you have structs, then like closures kind of fall out naturally anyways. So I think
You can fake your way to things where you badly need a closure, you can fake with a struct and a function. Yes.
you know what I mean is like someone like being inspired by Simple, then
Oh,
working on their own Sea of Nodes implementation, and then wanting closures, like they can probably find their way there.
They
It's
find their
just
way
not
there.
the
Yeah. Right. Exactly.
Hmm.
It's kind of like I wish Tommy was on. Tommy was doing like I think he's doing C++, Rust or C++. Anyhow, he's having trouble with like arena allocations and things. It's a funny place. Like people doing these implementations are all over the map of where their experience layer is. There's holes in people's experiences. It's very interesting to watch. And we have, I think Robert's Rust version is getting pretty close. I think he's right on my tail for implementation. All right.
I had one thing I wanted to ask you guys about. So I was thinking, what would be the advantage or disadvantage of having like both record and variant types, like some types in one like module syntax, and like what would be like I can write it in the code block. Like this is what how I define records in my language, and this is what I do for some types.
You said
It's like
this. Where are you putting them? Oh, down below.
yeah,
Okay.
yeah.
Yeah.
So the question is like, can I like is it cursed if I do something like this and then call this a module and then like because sometimes I notice there's a problem where I have lots of variants of some kind of some type, but they have like shared data. And then I need to split it out into separate fields. So I was wondering, I mean, yeah, I was thinking a bit about it, and the syntax is like not ambiguous, and so I was thinking like I don't know of any language that does that. Like
So the first one was records, and the second one is
yeah, variant like some type,
Tag union. You call it some type,
tag
but I call
union,
it tag
tag
union.
tag union, discriminated union, like
Yeah.
yeah, some type.
Yes,
You
yes.
know.
So one of the things I could do it simple, I've been thinking about it, was unify structs and arrays, where the tail end of every struct is also allowed to have an array body. And the reason to do that was like I want to go strings, then I put a bunch of functions in a struct that ends in a char8 or whatever U8 array at the end. But it's mixing, struct field, named fields with an array reference fields.
Hmm.
I don't see any issue here as long as you keep sorted out the tags from the not the tags. So
I
A
was
and B would be untagged fields everyone has.
yes,
Red and green are tagged variants, but you didn't say anything about them. So they get the A and the B, but nothing else.
yeah,
RGB, I guess, is another tag. It has three more fields.
yeah.
Hmm.
As long as the
So
syntax is fairly obvious, I don't see any reason to be unhappy. It sounds sensible. You can't have another unrelated tagged union under this kind of syntax. You get one of red, green,
yeah,
or RGB. You don't
yeah,
get
yeah,
also
yeah.
a
Like,
person.
I guess a way I would think about it is like in this case, foo is actually a tagged union with additional fields that everyone shares. So
Yeah,
it's like
I would
this.
right. I would call that a tagged union. Because if I want another tagged union grab together, I need to give it a different name. It gets a different tag and give it a set of fields, and then I can have a container that holds them both. Fine, whatever.
Yeah, so this came up because I was looking at like row polymorphism.
Yeah.
So right now I have like a basic implementation of something I call signatures, but it's basically like traits or interfaces or whatever. It's like the way I want to do polymorphism eventually. And then this row polymorphism came up, and I realized I can like in my signature or trait definition or whatever, I don't need to only put like oops. some kind of function. Like this is the common thing, like you put some function that it needs to fulfill, but I can actually just paste the type like fields in there. So really a signature or like a trait or interface or whatever can really look like the module itself almost. So, but then I realized this only like row polymorphism is mostly done for record types, not for type for some types or like typed discriminated unions. So I was thinking, can you do some kind of row polymorphism, but
I don't
on
know.
like I mean I can just do this thing here as well.
So what would claim here? Under here we have a structure that has to have these fields.
Yeah, or in this case, it's like these are tagged union constructors. So like the S is a constraint on a type that basically says you need to have these three things in your in your whatever your tagged union. And then this is just like a member, typical, like some function. So I haven't seen that done. Usually I see row polymorphism only discussed in the context of records, but tagged unions are such a common data structure, and I don't know, maybe this is super cursed because yeah, the reason I was thinking about it is because I also thought struct embedding is cool. Like, there's this feature I think Go has where like let's say these three things I can actually oops. I can just put them into color, and then in here, instead of listing every tagged union constructor again, I can just say something like embed or inline
Inline.
color. Yeah. So yeah, and then in this way, I actually fulfill the signature. It might be super over-engineered, but I feel like just this
Is
ability
inline color that different than just having C:color as the third field in your foo?
Yeah.
Well, one difference would be that now foo itself fulfills this signature, this constraint. I mean, yeah, I could like, yes, you're right. Like this is, I need to come up probably with good examples. Like, why not do it this way? Why do I have to like
Yeah,
inline
that's my
anything?
question.
Right. It's a good point. I'm not sure. I was just curious if this seems interesting or if anyone has like clear issues with it or has seen something like that before. So yeah.
I have not coded in anger here. I coded in anger on Elm, which had these tagged unions, and that some places worked great, some places it sucked, but I didn't have to do what you're talking about with the row polymorphism. That was never part of the thing.
Yeah, one thought that I've always had as kind of half a thought in my head that I've never quite finished is I feel like tag and union are concepts that could be pulled apart. So that my union type is really just a union type. If I say int or string,
Yeah.
it's an int or a string and
Yes.
does not necessarily have to be tagged. And if I say union of int and int, that's
Yeah.
just an int because unioning a thing with itself. And then have a separate concept that says this is a tag. Now, if the two things in my union are a tagged int and a tagged string, now it's going to be different behaviors because I have added the tag and
The
simply.
community for a long time has had this notion of the tag is separate from the data being unioned. It's a tag union, but the tag is over there and the union's over there.
Right. And the reason I want it is that I want to split the two concepts of I could have a tagged union where my tag is essentially a string. Anyone who knows the string can make one of them and can comply with it. And now different things, you don't have to like all import the same library. And the other one is to do the exact opposite and say, I want my tag to be a symbol that is imported from this package. So literally no one will ever collide and manage to implement this tag who has not imported my thing and put that symbol
But
there.
by default in JavaScript, everyone uses string tags, they're tag unions. And like FlowScript and TypeScript both recognize that you're writing a tagged union without having typing support in the language by using string tags. And they'll come up with the tags that are being used and tell you the type they'll do.
Right.
They'll infer the type for you. It's a tagged union with the following string
And I
tag.
feel like those are both useful concepts. I feel like this is a tag where I have Any two structs that have the same set of fields should be equal, irrelevant what the type are, because they are the exact same fields and they are exact same values in those fields.
As soon
And
as
the
you
thing
do,
that should break structural equality is if I wrap the two things in a tag, the tags aren't equal. Now I'm not going to go into field equality because the tags weren't equal.
I mean, this is
And I think
was
it's really convenient to have
use the fix.
tag
Fine.
that can take a symbol, tag that can take a string, or just leave things anonymous, and it falls down to structural equality.
I thought about having the tags separate from like the data, but I could never find a good use case. Like I always end up just not using it, and then I'm like, I just scrapped the idea. I just couldn't find the use case.
I've seen it built in old C programs where, due to density reasons, the tags were kept separate. But it was effectively a tag union struct, but you asked one place to get the tag to understand how to parse the data in the other place. But it was all due to tiny machine sizes and how tight to compress the data, make it fit it all, as opposed to some sort of high theory thing which says there is the tag data, here's the tag, and here's the union, and they're separate. And because they're separate, I don't know, whatever reason, I have them separate. They did it because necessity, and then they fucked up all the time and got the tags wrong and got the unions wrong, and you went debugging. That's what it was.
So, foot guy?
Maybe some kind of annotation.
Yeah, I don't know what to do with that one. Split the tag out? Why not? Same as my compressed columners. Them tag columns compress nicely. Why not put them in a side array? Okay, now you have. Where's the typing on it though? I don't know. And that's not even answering Adrian's question here. Is it useful? I think it's useful to have common fields along a tag union. That's certainly useful.
Yeah, I think maybe, yeah, right. Like this struct embedding I mentioned, this inlining, that's probably a bit like unnecessary, but I think having like fields alongside the tags seems like I feel like I had to use it quite a few times.
Yeah.
There's actually a very particular kind of boilerplate that is very common in Rust, and like you would write something like a typical tagged union in Rust would probably look like this. You have something like
Your names are too long. V1, V2, V3.
sorry, you're right. I just want to like kind of stress the boilerplate part about it.
What was the passing it to the same thing?
Well, that's the horrible part. I mean, it doesn't allow you to
The first one's a
add,
symbol, the second one's a type.
yeah, then you do this, and then there are some fields in there, and you do this for
This is how I see.
yeah. So like there's no way to declare anonymous structs. Like so this is like one source of
No.
boilerplate, and then the second source of boilerplate, what if V1, V2, V3 share all of the same fields except let's say maybe one field or something like that. And in that case you get lots of repetition.
Right,
So
in Elm for sure, you had, I guess you would call it the anonymous struct with each of your tag unions. You had a list of data with each tag union. There's no question about you didn't do this kind of repetition. Tag V1 has the following fields, arrow, and here's the function that went with it or whatever.
But yeah,
but
I
yeah,
have seen
anyways,
in Rust a lot of the like
Yeah, right.
enum message type 1 is of type message type 1, message type 2 is of type message type 2.
Wow. So there's
And
no
then you have a
anonymous
struct for each of your
structs.
message types.
That's the trick. There's no anonymous struct that you just declared inline in the enum. The enum has these fields.
yeah, I guess another way also of looking at this problem is that this thing here on the left, this name is not a type itself. So you kind of like this is merely a constructor and this is a struct. So there's like a few issues with this. The kind of
Java is actually closer to that model. The enum tag is really actually a constructor for a subclass of the base enum class. So if you have an enum foo, you can put common fields in enum foo, but then each separate enum underneath is really actually a full Java class object being declared inline. So it's an anonymous class. And you can have all kind of fields and functions that are enum specific. Not claiming that's the right way to do it, but seems straightforward in looking at your example. And when I look back at my Elm examples, I had something similar. This looks, yes, very repetitious. All right, I'm going to declare victory here pretty soon.
Yeah, I think variants are still kind of hard to work with, and I'm surprised that we have not gotten better at that yet.
Boy, when I've had good support for them, Elm, they were very nice. There are things I hated about Elm, but that was not one of them.
Can you say more about like what made that a nice experience in Elm?
It was just a common experience. So I'm using Elm to do the GUI, and the GUI is fairly rich, and it's a big data exploration GUI. It has lots and lots of parts moving on it. Okay, fine. A lot of events would come through the main event loop, and you had a tag union for every kind of event. I clicked here, I clicked there, I clicked this, I drugged that, I hit the keyboard, I typed this, blah, blah, whatever. There are 1,000 events come through the event loop. They all were under tagged union. And then the tagged union described the set of events that you knew about. And then in the main loop, you had a breakout for all the events that did something. Hey, it's time to go change the model, the view, the controller, whatever, it was an MVC kind of thing. But in other places, you took the tagged union and it had all the parts that were, the user clicky GUI bits, and you did things with them. I broke out the XY coordinates and I looked up in my 2D array and I figured out which element you were clicking. And then I did a zoom factor and I changed all the blah, blah, blah. And you did all the model control thing. And you have a bunch of stuff. So it was a nice way to break out a series of things that were falling under one header, events, but within each kind of event, there was a unique breakdown. Effectively, just as a Java class, effectively the enum was a class and every little variant was a subclass of the base enum class. That's how Elm did it. That's how Java does it. I guess I've done it in Java some too. It's a reasonable.
That reminds me a little bit of the way Python errors tend to work, is that you just make your error extend error.
Okay.
So if you have a function that returns an error.
I'm living with a lot more, I'm gonna say a lot more variety of things I was doing than what I normally do with errors. Like errors, maybe I extend, maybe I don't. I throw and I'm done. I don't touch the error again. Whereas in the tag union case, I was looking at those tags and looking at the variant fields and doing things about the variant fields. It mattered. I did things with them, and it was a reasonable experience. That part was good. The other parts, like I said, some parts of Elm I hated. That was not one of them. That was a good part. Which means that I probably should do something with them in either AA or simple or both.
Have you worked on ecstasy in any point in the last few times?
Well, I've not written any code in ecstasy. I'm busy implementing it, for which I will endlessly curse and swear Cameron's choices.
Like what?
But I'm not actually writing any code in ecstasy. One of the things that always goes on in my head is, what is the mapping of what I typically write to the cost on the hardware? There's always a cost model running in my head. And on ecstasy, there's huge amounts of, I would say, unnecessary cost thrown in for all the abstractions. I can get the same behavior done so much cheaper, so many other ways. I just like, no, stop now, fine. But I'm going to implement it faithfully, but it's going to suck, from my opinion. And I've told Cameron plenty, and he's too happy with where he's at. And he's paying the bill, so okay, fine.
I mean, I do think there are real trade-offs between developer ease and cost model.
No complaint against that. I'm thinking that you could have the nice developer experience on a thing that also has what do you want to call it, mechanical sympathy, that can be made to efficiently boil down to something that will run reasonably well. If I give you a language that you write in, and it's called R or Python, and you wrote something and it's great, and you hacked and you hacked and you wrote and you hacked and it's great, and you got a big complicated program, and then you hit the scale up button and suddenly it doesn't run, and you have to bail out of the R Python models because performance is just so bad, It works great at the 1K level. It sucks at the 1 meg level. It's simply impossible, literally impossible at the 1 gig level. Just does not work. So, okay. So then I changed models. Well, what was the point of having that model that you had to love on in the beginning when it was small and it didn't scale? Can't I have both? Didn't we start this whole CCC with, isn't there a way to have the fast, efficient,
Yeah.
good turnaround that you get out of Python REPL and also fast, efficient, big data?
It's making
What?
me think of the sort of common case that I think of as the default for this thing is I want to do hashing. The logical thing that goes on is I'm calling SHA-256 of string. It gives me back a hash.
Yes. Yes, there you go.
But I actually get much better performance if I, at the beginning of my loop or context or whatever, say, allocate me a hasher that's going to have a little bit of memory. And then I hand it the chunks into the hasher. And then when I'm done, I call hasher.clear that sets it back to the initial state to go back to the beginning.
Yeah.
That feels like the kind of thing that could be done better, where I just write hash equals SHA-256 of string, and the function call is init the hasher, do the hash, clear the hasher, and then that gets hoisted up to the beginning of the for loop or context, or like in the same way that we hoist the null checks out of the expensive place, you think you could hoist the allocations out of the expensive
like the hoist
place.
the allocation reuse, and that's lifetime management at the compiler level. And right now, the state of the world in those is that the escape analysis is very weak. And if there is some syntactic way to write things that you could tell, I wrote this hasher, new out hasher in the body of the loop, but it's really lifetime's just a loop. Do one new outside. Yes.
Is there a language where it's slower to use the function?
I'm not sure what you mean by slower to use a function.
What Aaron said, he said about using a function is slower than calling the multiple.
Yeah, in Python, I can call the do a hash directly in one line, but eventually you get to the point where someone goes, oh, the profiler's crying right here because the allocation of that thing every time inside the loop is dwarfing the cost of the cryptographic hash function.
Yep. So here's
that's not even that cheap of a CPU thing to do.
Here's the thing, Levo. For the first order business or the first order cost model in the universe is count your cache misses. If you allocate using a bump pointer allocator, that will always guarantee give you a hard cache miss to main memory with each bump. So if I have a loop and I say 4 billion times, allocate a hasher object, it's 64 bytes, it's small, then a hash, then consume the hash and carry on, go again, then I'm burning 64 bytes for a billion times. That's 64 is a cache line, that's a billion cache misses, that's my cost. If I move that hasher up out of the loop and I say, fill the hasher, crypto it, go again, fill, go again, I just removed a billion cache misses from this loop. That's probably a big chunk of the cost. So you looked at the billion row challenge. Everyone starts out by doing something reasonable, and then immediately they die cache miss costs. And the next thing they do is they cache everything, they hoist everything, they move all allocations out. They get 10x, 50x faster, like huge count faster, no allocations. But now your code looks like shit. Can't you get the compiler to do that hoisting of that allocation out of the loop? Well,
I would imagine that what Aaron said was should have been already done in Python, but I don't really know.
Python says I have a loop. 4. What's the body?
I don't even think
know.
it's done in Java.
Yeah. Even in Java, if I say I have a loop, I say 4. I say new in the loop, then I use, and then I don't touch the object again. I go new on the next go around. That's actually still a fairly hard problem to say allocated, used, consumed, done, lifetime ended. Oh, allocate again on the next iteration. Can't I do this allocation once up front and recycle myself? That's a hard problem to do, and Java is way simpler about this than Python is.
I would have thought that that function would be implemented in C or whatever, because it's a standard function.
No,
I mean, is it a standard library function?
I'm talking about the user wrote something.
Oh yeah, that's
the
different.
Wrote something. The compiler gets presented the following code. for loop over a billion, new tiny object, stuff some fields, load some fields, never see tiny object again. Can the compiler in that situation hoist this allocation out of the loop? That is a hard problem. It can be done. It's a hard problem. It's also very fragile, and that very many not very interesting looking things immediately break that analysis, and then you don't get the hoist. But
How about oh yeah, Bill?
Oh yeah. Oh, sorry. I had a question
Bill, yeah.
before you go, which I didn't want to stop your thought though.
No, go.
Go,
Yeah,
Bill.
I was wondering, like, how often does memcpy cause a cache miss? Like at certain sizes, I suppose it depends on.
Memcpy never causes a cache miss per se. It is
Well,
the source or the dest not being in cache that causes a cache miss.
but is then there a size beyond which it won't fit? Like you'd have to be like at least half.
It's not right. It doesn't matter about fit or not. It's whether the source or the dest are in your cache. Yes, there's a size for which it doesn't fit, but that's not the issue. The issue is I had a billion things over here. I have a giant pile of things over there and a giant pile of things. I'm going to move something from here to there, but they're all out of cache. So it's just a hard cache miss.
Right.
It's one cache miss each way, two cache misses. I don't care. I move a billion things. Okay. If I had a million things and they will all fit in my L2, I load a million things in my L2, all misses. I write them out into main memory, all misses. Okay, and now I never touch them again. There's no reuse. I don't save myself the million misses for the next go around. So it didn't help that they fit in L2.
Okay, I didn't quite follow that last.
So the hardware prefactor is pretty good at spotting that pattern.
Yeah, yes, but then that limits you to your bandwidth, which gets to on an x86, 1 core, 2 cores can burn all your bandwidth, and you have 4, 8, 16 cores, and there's no bandwidth to go. So let me go get Bill over the hump here. Suppose I have I'm doing memcpy. So your poster child is memcpy because he touches memory a lot. But the source memory is not in my cache because wherever it came from, it's not in my cache.
Right.
Okay, touching it means a cache miss. We hope the prefetcher kicks in and covers some latency up to the bandwidth of the CPU, but it's all misses coming into my L2.
Yep.
Everything in L2 gets wiped out, and L2 is filled with the things I just memcopy into, and I'm memcopying out to memory, which also has to get written out, and that eventually eats bandwidth too.
Yep.
Okay, now I'm done, and I never ever touch that memory again.
Okay.
Well, I just burned off my L2, and now I have to I have to reload my L2 with other good things. There's no reuse. If there's no reuse, then all the caches in the world never help. Typically, there's tons of reuse.
Yeah.
But in order for, and then you want to say, well, what's the cost? Memcopy from L2 to L2 is, pretty cheap. Memcopy from main memory is not.
Right.
So it's about the cache misses and not about the memcopy.
Well, the reason, the motivation is, like last week, we're talking about array and array list.
Yeah.
For mutable, that makes sense to me. But if you want to make an immutable data structure, it seems like you'd want to have like a little chunks that you can reuse. That at some point, it's actually better to follow a pointer because I get the reuse when I transform an immutable data structure into another one, like a sequence. Right. But if you make that chunk too big, you start like there's some point where I think you get the diminishing returns on the size of it because you do have to copy the chunk size.
So what you're saying is I have this data structure that I'm going to fake both mutable and immutable by letting it be immutable and copying as needed to make it mutable. What as another way to think about this is as I run, I continuously produce new data that I never get rid of the old data. It's always left lying around. And eventually I run out of memory because I've only ever produced new memory and never deleted any. So, oh, wait a second, that's not what I meant. What I really meant was that I ran for a while, and then as I made new things, the old things eventually go dead, really, and then I want to recycle them. That's a standard garbage collector. Has the same issue as just talking about.
Yeah.
The usual story is the garbage collector won't run until long past all caches have been filled many, many times over. Which means that when you go ask for some new memory because you want to change the thing, the new memory you ask for won't be in any cache level hierarchy. It will be a hard miss. And as you bring it in, you're going to write out some dead memory that you haven't used in a while, but it's actually probably really dead, but the garbage collector hasn't run to tell you it's dead. So you're writing out dead memory. So statistically speaking, you're writing out dead memory. 100% reading in dead memory because you're going to fill it with zeros and then data. And statistically speaking, you're writing out memory that is dead. 99% of it is dead. So it's all just burned memory bandwidth.
Yeah.
And 2 cores on a modern x86 will eat all the memory bandwidth that's available for that chip, which means if you have an 8-core system and 8 of them do these things, well, you ran out of bandwidth at 2, so they're all running at a quarter speed. 100% CPU load, 100% max CPU, but the throughput they achieve will be the same throughput they get out of 2 cores. And the other 6 might as well go home. And this is a standard common operation with modern hardware. You replace that with, I didn't allocate because I moved it out of the loop and I recycle. Suddenly all the cores have bandwidth for the little things they need, and they have CPU cycles out the wazoo, and you get this huge speedups. That was part of what made the billion row challenge go fast. You arranged for the fact that no one had extra bandwidth burn other than reading the raw data set. And then they went as fast as raw data set divided by CPUs.
It goes back to what are the language design decisions that let you do that hoisting more reliably and more predictably to the developer.
Yeah, yes. So the developer can look and say, oh, this will happen, and I know, and it's all good. Well, if I tell the developer, put that allocation outside the for loop and recycle it yourself, the developer just did a malloc-free lifetime management in his head to say, oh, I know this thing is dead at the end of the loop. And so it'll recycle, and I can get the performance. But I made him do the memory management lifetime. That's one way. Is there another way?
So you need the developer to write del variable name at the end of the loop, or?
I don't know. I know that it's the problem with the alias analysis as happens today is that so many things can break it because you don't write these very simple patterns. You know, we just wrote a pattern, we discussed a pattern. This is too much of a straw man. For new, write, end of close, curly at the end of the loop, I can look at the lifetime and say, you didn't escape that pointer. Okay, as soon as I have complicated functions that I can't see all the way down the line, the fact that you escaped or didn't, that pointer is lost to me. And as soon as that's lost to me, I can't hoist it out of the loop.
Maybe the problem is that you just allocating, you just has to say new. So maybe you have to restructure somehow the function to, not allocate.
Russ comes along and says, you borrowed this, and then you unborrowed when it came back. And at the end of the body of the loop, everyone talked about they borrowed and they unborrowed, but none of them owned. And the reference dies at the end of the loop. Poof, I can allocate it outside the loop and life goes on.
But I think the answer is it's actually a ternary decision of, I think this escapes a lot, so I need to allocate something new. I think this escapes rarely, so I need escape detection. Or I think this never escapes, so that I can do the super cheap thing.
Yeah, you have to.
What was the first case?
The first case is this escapes a lot. I have to allocate a new thing, bump the pointer.
So that is the analysis, the profiling thing. This is actually what I was doing at Azul. So profiling.
But the second answer is this escapes not a lot. So I'm going to assume that I can just reuse the same memory, and if it ever does escape, at that point I call new.
The one where you say it escapes some of the time, I have to emit code to detect escaping. But that code to detect escaping is vastly cheaper than the cache miss that comes from the escape.
Right. It's less cheap than never escapes, but it's more cheap than escapes a lot.
Yeah, and that was the benefit I had of escape detection, is it would work on these complicated programs where I couldn't get an analysis to validate it didn't happen. Whereas the Rust thing says, I strongly tell you in the typing system, it does not escape. But to do that, you have to annotate the fuck out of the program. You spend all your time writing these complicated borrow annotations. No, that's not true, but you spend a lot of effort on it. Is there a better way that says there's less effort to write these annotations, and I also can tell you it didn't escape? I don't know.
I mean, my experience with the annotations in Rust is that it's a little bit like bowling with bumpers. When you first start with Rust, you get to the end of the aisle by banging against the rail 7 times.
Yeah.
And then after you've been doing it for a while. You just sort of get into your head the patterns where you're not going to hit the rails anymore.
So you can learn and become productive. Must be some people are productive in it. There's clearly there are.
Which I think is what's happening with C++ was that people, it's not that C++ memory management isn't bad. It's that eventually you get to a point where you've just like narrowed your focus to the point where you don't reach for the things that would have really nasty lifetime
Doctor, it
management
hurts
problems.
when I do this. Don't do that.
And I think of Rust as just, rather than bowling with gutters, you're bowling with bumpers that tell you, no, go that way.
I don't have to go fish the bowling ball out of the back alley where it landed after a crash happened. Gotcha.
That's
For
the
what
C++
it's worth.
model. It's if you didn't bowl it right, it's
just
And-
gone. Yes.
Like as a
It's
data
still-
point, like for Rust, I think my compiler is like now 8 or 9,000 lines of code. So it's still pretty small, but
Small,
I've
yeah.
basically no lifetime annotations anywhere. I just have like tons of arena allocators, indices everywhere, compressed indices, compressed pointers, compressed slices.
You have the other
every-
problem then. You lost type safety. You went from a node
Yeah.
pointer or Persian pointer to a number.
I mean, what I do is I do have like this thing where I wrap indices and then I add an indexing method to particular arenas. So there's still type safety. Like you can say this arena is only allowed to be indexed by this
This kind
particular
of index.
wrapped integer. So
Okay.
there's still
All
something
right.
to get.
There's some compiler type safety. It says I have a.
Yeah,
I have
but
a-
no lifetime
Oh, that's
annotations.
that's on the
Nice.
arena. So if
Yes.
you have a pointers to a node and a pointer to a foo and a pointer to a bar all in the same arena, you can mix node, foo, and bar indices up, but you can't mix up indices from this arena with indices from that arena.
Right. Yeah, on the arena it says this is an arena of expressions, so it contains expression IDs. It is indexed by expression IDs. Same with statements, functions,
Okay.
types, all
But
that
you
stuff.
don't mix them in different arenas because if you do, you'll.
Yeah, you're right. I lose some safety for sure. But
Interesting.
by the way, there's
Oh.
something I posted in the doc just as an explanation. This is the last link there. It's because not the new combinator, the thing above
True.
the
What?
third link, I think. Oh, wait.
Mario meets Burrito?
Yes, Mario meets Pareto. It sounds like it's not compiler related, but it is. So Aaron mentioned this thing about like trade-off between developer experience and like language performance and stuff. And I had this discussion on a forum recently where people seem to believe that somehow everything is a trade-off. Like there's no such thing as a objectively better in every particular criteria or metric. But it turns out,
Oh, that makes me so mad.
yeah, the thing is like it turns
All
out
right.
you can actually do
Technical
some
related
things
types,
better in many ways. Like not everything is always a trade-off. Like there's legitimately ways to improve things on all fronts. So I had this discussion and this visualization is pretty nice because it's just a video game where you choose a certain combination of like characters and
Yeah, I mean, I'm aware of Mario Kart. My kids played it for many years.
Yeah. So you have a bunch of combinations, and like there's particular metrics like speed, acceleration, drag, all the kind of things, and there is a certain subset of candidates that are considered to be optimal, like Pareto optimal, and I think it applies to languages. So,
Yeah, could be. Well,
I have a friend who did that as his senior design project in college. He was an industrial engineering major and downloaded all of the possible gear that existed in World of Warcraft at the time and was like, I am going to find the set of non-dominated builds because some builds, there's another build that is better on every single statistic.
Right.
So the only builds that are interesting is the non-dominated builds that in at least one statistic they are better than every other one of the non-dominated builds.
And what did he do with
And
it
finding
then?
an efficient algorithm to do that was enough to get him a undergraduate thesis.
Oh, I bet.
Nice.
All right. I'm getting hungry and my stomach is growling here. It's time.
Yeah, I got one comment. I still don't understand why people still struggle with like memory management in C++ or C. after they've been doing it for a year. Because I remember Cliff was saying before that whoever allocates should be the one that frees, and there's like other rules you can follow. But it's still surprising to me that people still struggle with it after many years.
The entire Rust community is baked around the notion that it's hard to get it right.
It's not. It's not hard at all. I literally taught it to my sister who doesn't program.
Okay. Well, I think you need to work on some of these big projects where they haven't quite got it right because they got too big.
Yeah, the
Crack it
usual
well,
rule
and
I've
then start
heard is
sorting out.
40 engineers.
Yeah.
If it is less than 40 engineers, you can glare at someone for having violated the memory management tradition of your
Oh,
project.
yeah, that's that.
And if it's more than 40, then there's at least one person who doesn't care if you glare at them.
Yeah, there's that, right. You need a process that fixes the issue that's not shaming. You have to do something other than public shaming. It doesn't scale. All
I
right.
mean, it scales to 4 engineers just fine.
But if it scales to 4, just fine. You broke the build, you owe chocolate. That was a rule at I would say at H2O for a long time. If you broke the build, you owed chocolate. Or lunch out or whatever. It's a little bit of fun version of that. But yes, and then right.
Donuts.
And hotspot, and it was 70 people working on the hotspot build, and you broke the build. You just had to have a different strategy here. All right, I can be done. See people next week. All right, bye-bye.
See y'all.